Welcome to the Explainer. Today, we're going to build a fortress, not with, stone and mortar, but with code. We're going to dive into the essential tools and strategies you need to create software that's not just functional, but genuinely, truly secure.
So this is really one of the biggest questions in software development right now. It is no longer enough for an app to just work. It has to be a fortress, right? It's got to be able to stand up to constant attack. So how do we actually bake that kind of strength into its very DNA from the start?
Okay, here's our game plan. We'll start with why this is such a problem. Then we'll get into the actual construction, reviewing the blueprints, vetting our suppliers, testing for attacks, and then we'll see how it all comes together in a layered defense and a real security-focused mission.
You know, the old way of doing things, the really old way, was to just build first and then worry about security later. Some security team would come in at the very end and try to patch up all the holes. But in today's world, with these incredibly sophisticated cyber attacks, that's like building a castle and only checking for weak spots after the enemy's already knocking down the gates. It is just a recipe for disaster. So the answer is this pretty radical shift in thinking. You've probably heard of it. Shift left. We literally move security from the end of the pipeline all the way to the very beginning. This is the absolute heart of DevSecOps. It's about embedding security into every single stage of development, from that first line of code to the final deployment. It's about building resilience in, not just bolting it on as an afterthought.
So, our first step? We've got to go back to the blueprints. Before a single brick is laid, we need to scrutinize those architectural plans for any hidden weaknesses.
In the software world, this is called Static Application Security Testing, or SAST. Now, think of it as a white box method, because it has a complete unobstructed view of the app's internal structure, the code itself. It's kind of like having an expert architect poring over every single line of your blueprints, searching for flaws before you even think about starting construction.
So, the greatest strength of SAST is, without a doubt, its ability to find problems super early in the process, when they're cheap and really easy to fix. But, and this is a big but, it has a major blind spot. It's only analyzing static code, so it has no idea how the application will actually behave in a live environment. It's fantastic for finding things like hard-coded passwords, but it's going to completely miss issues that only pop up when the app is actually running.
A fortress, as we know, is only as strong as the materials you use to build it. If you're using weak stone or faulty timber, it really doesn't matter how great your blueprints are. So the next step is making sure your suppliers are giving you secure, reliable components.
In software, this is called Software Composition Analysis, or SCA. And let me tell you, this is absolutely vital. Why? Because pretty much all modern applications are like this giant patchwork quilt of open-source components. So SCA tools are your inspectors. They meticulously go through every third-party library in your project and check them against this massive database of known vulnerabilities.
Okay, so the crucial point here is that SCA protects you from the risks in the code that you didn't write yourself. It's all about managing the security of your software supply chain, which, believe me, is often the biggest and most overlooked attack surface. This is how you prevent the next Log4 shell-style crisis from totally crippling your application.
All right, the blueprints are solid, the materials are vetted, and our fortress is finally built. Now for the fun part. Let's see how this thing holds up against a real attack.
Okay, first up we've got DAST, Dynamic Application Security Testing. This is what we call a black box attack. The tool has no idea what the internal code looks like. It just hammers away at your running application from the outside, trying to act like a real hacker would. It's on the hunt for those runtime vulnerabilities, things like SQL injection that could trick your database into spilling all its secrets.
And next we have IAST, or Interactive Application Security Testing. Now this is a much more modern, kind of a hybrid approach. It actually works from inside the running application, almost like a spy. So as the attacks are coming in from the outside, the IAST agent is monitoring the code in real time, giving you this super detailed play-by-play of what's breaking on the inside.
And here's the key difference. DAST is great at telling you that a door was breached, but IAST can tell you the door was breached because of a faulty lock mechanism located on line 257 of the code, and here's the malicious data that exploited it. It provides that critical context that developers need to fix the real problem, and fix it fast.
Okay, so now let's see how all these tools come together to form a complete defense strategy. Because a single wall, no matter how strong it is never enough. You need layers.
Look, each one of these tools we've talked about is powerful, for sure, but each one has its own blind spots. SAST can't see runtime errors. DAST can't see vulnerable code that just didn't happen to get triggered during a test. And SCA doesn't look at your custom code at all. Real security only comes from combining them to cover every possible angle.
This table is basically the ultimate cheat sheet, tying our fortress analogy to how you'd actually use each tool. And pay close attention to that when to use column. See? SAST runs right there in the developer's environment. SCA should be running all the time, every time a new component gets added. And then DAST and IAST, they come in a bit later, testing the fully built app in staging before it ever goes live.
And the benefits of doing all this? They are huge. When you layer these tools, you find vulnerabilities way earlier, which drastically cuts down the time and money it takes to fix them. It actually improves collaboration, it reduces all that noise from false positives, and it just gives you the confidence that you're building software that's compliant and genuinely secure.
But here's the final and maybe the most crucial point. Building an unbreakable fortress isn't just about the tools you buy. It's really about the mission and the culture of the people who are actually building it.
This quote just nails it. A mature security practice isn't just about owning the right tools. It's about orchestration, making them all work together, totally seamlessly, as part of a culture where security is literally everyone's job. This means creating automated security gates in your build pipeline that physically stop vulnerable code from reaching production, and creating feedback loops where security findings are treated as a chance to learn, not a reason to point fingers.
So, as we wrap this up, this is the question I want to leave you with. Is your security a fundamental part of your software's architecture, a true fortress? Or is it just a simple locked door, really just waiting for a skilled attacker to come along and find the key? Ultimately, the choice is in how you build.